that even roots on problem 25, even roots have plus or minus answers. But in the instructions it just says simplify, so that's why we only do the positive root. Does that make sense? The primary root. Okay, so this one we already done. So 96 broke down into 3 times 32. Yep. 3 times 32, and then 32 breaks down into 6 times 8, right? Oh, was it 8 and 4? Yeah. 6 times 8 is 48. Okay, sorry. You say 8 and 4. That's true. And then 8 breaks down into 4 times 2, and 4 breaks down into 2 and 2, and 4 breaks down into 2 and 2. Okay, pulling out groups of 4. 1, 2, 3, 4 2s that can come out, correct? So that's really, we're pulling out a 2, and then left under our house was a 2 and a 3. And then remember, we could go ahead and say there's 6 m's under here. How many groups of 4? 1, correct? Or we'll do 6 divided by 4 once, evenly, correct? So we'll pull out m to the first, and then left under, you have to write a 4. The fourth root left underneath was 2 times 3, which is 6, and there was 2 m's left underneath, which is m squared. Now, everybody good with that? You've already got that one, right? Okay. So 29, I saw people get it wrong, something wrong on the quiz. Is the fifth root of negative 96 going to be I? No, right? It's just going to be a negative answer. Okay, good. Just making sure. We've already done that one. We've done that one, and we've done those. Okay, we've done all of those. Okay, here's where we're going to look at. 64. Let's all plow through this, simplify it very quickly. Let's look at it in sections. Most of these come out even, so these ones are very quick to simplify. What's the square root of 81? If we're just simplifying, we don't need plus and minus. What's the square root of 81? 9. 4 divided by 2 is? So 9x squared. Is everybody comfortable with that? Okay, looking at this, the square root of 121 is 11. And then y to the 5th. Do we have any questions? Cube root of 8 is positive 2. And then 6 divided by 3 is squared. And then cube root of 125 is 5, and then 9 divided by 3 is 3. Now, this one, we would look at it in sections. Multiplication can be split up. So we have the square root of 25, which is 5. The square root of x plus 2 to the 4th. 4 divided by 2 is, so we have x plus 2 squared. This one we're going to split up and look at it in sections. The cube root of 64 is, it's 4. Cube root of 64 is 4. And then cube root of x to the 9th is 9 divided by 3 is 3. And then cube root of 343 is 7. Is everybody comfortable up to here? We've just simplified them. And notice these all came out pretty. There was no radicals left, which doesn't always happen. Awesome. Okay, what about this one? The fourth root of fourth root of x to the 4th over 81. We split it up. So what's the fourth root of x to the 4th? And then the fourth root of 81 is 3, so that would be our answer. And then the next one, square root of 36 is 6. Square root of x squared is, and then square root of y to the 6th. Y to the 3rd. Is anybody confused on how we're getting that? Please ask if you do. Okay, moving on. How about this one? This one you should be able to tell me right off the bat. What's the answer? M minus n. Root cancels out power, m minus n. To the first power, technically, correct? All right. So now that was not new to us. This is where secondary 3 we build. So secondary 3 we build by, sorry, I'm a little bit lost because you guys were behind my other day. Right here, this is a new rule. So when simplifying radicals, when simplifying even roots, you might need to put absolute values in your answer for variables only. And I'll explain why in a second. So the rule is, write down this rule somewhere. This is when you need absolute values, and I'll show you what I mean in a second. This is the rule. Write it down on your paper somewhere. If you have an even root, and it's only in this exact order, if you have an even root and your answer's exponent comes out odd, then you need to add absolute values, and I'm going to explain why in a second. But let's just get the rule written down first, and then I'll show you the rule and explain why. So if it's an even root, and your exponent comes out odd as an answer, then you need to add absolute values. And I messed this up. It should look like this. So we just add absolute values. There's our answer, and we need to add absolute values. Even root, odd exponent, add absolute values. Okay, everybody look up here. So in this example, we have the square root of x to the 6th. Is that an even root? 2 is an even root. Now, what did it simplify to be? X to the 3rd. Is that an odd power? So it went in the order, even root, odd power. So we need to add absolute values around it. Now, here's why. When simplifying something underneath a root, an even root, like, for example, are we ever going to have an answer come out negative? Can you take the square root of anything and have it come out negative if we're just simplifying? No, right? Now, isn't x cubed, can't we potentially plug anything into this? Can't we put in -2 here? -2 to the 3rd is -8. So is it okay to have a negative answer? No. So we put absolute values to say that is our answer, but it's always the positive answer of that. Now, here's why we don't need it if it's even. Think about even. Let's say that this answer came out x to the 4th. Isn't anything to the 4th power going to be positive? So it takes care of any negatives for us. So the only time we need it is even root, odd exponent, then it's going to be a positive answer always, so we put absolute values. Now, odd roots, can't they have negative answers? So you don't need absolute values. It's only in that exact order. Even root, odd exponent, add absolute values. All right, so let's go back to 64. Here we go. Let's add absolute values where needed. Even root, odd exponent. So it takes care of all, that's making it positive, correct? So we're good. Moving on. Even root, odd exponent. Yes, now 11 is just a constant. We're never going to be negative. 11 is positive 11. That doesn't need absolute values. This that has the unknown needs the absolute values. All right, even root, nope, so we don't need absolute values. Even root, nope, so we don't need absolute values. Even root, yes. 5 is a constant. Even root, odd exponent, nope, so we don't need absolute values. Look at this one. Cube root is not an even root, so we don't need absolute values. Okay, what about this one? Even root, odd exponent. What's my exponent? Is 1 odd? So we need absolute values. Now we do not need absolute values around 3. 3 is just a constant. So if we were being smart about this, isn't this the same thing as this, everybody? 1/3 times the absolute value of x. Just saying. Aren't those the same thing? Okay. Good. All right, let's check this one. Even root, odd exponent on x. Yep, let's check the next one. Even root, odd exponent on y. Yeah, so we need absolute values, and we can put it around all of those together. Next one. Even root, odd exponent. Yes, because this was actually n minus n to the 1st. So we need absolute values around n minus n. All right, sweet. So what I want you to do is 64 through 66 we've already done. But go back. So you're 64 through 66. Sorry. 64 through 66. Do not skip the story problems. Do those. And then go back to problems 23 through 34 and add absolute values when needed. Now, I didn't say this until I confused people last hour. So let me show you something. Let's say we took the square root of something and got this answer. Watch, so the next part doesn't get confusing to you. Let's say we had 2x, y squared, square roots of x, y. So, even root, yes, odd exponent on x. So we need absolute values, true? You only put absolute values on this part. You never put absolute values underneath the radical. Does that make sense, everybody? Okay, so what you're doing right now is 64 through 66. And then you're going to go back to problems 23 through 34 and add absolute values on your answers when needed. That's all we're going to do before lunch, and then we'll move on after lunch. So do that before lunch, and then we'll move on. Unless you get that done quicker, then we'll move on. Let's see what you can do. So 8 breaks down into 4 times 2. 4 breaks down into 2 times 2. Because it's a square root, we're pulling out groups of 2. So we can pull out a 2, correct? Now, we already had a -4 on the outside. We just pulled out a 2. So -4 times 2 is So we have -8, and left under our root was a 3 and a 2. So -8 square roots of 6. Now we can multiply those two things, but if I changed it to addition instead of multiplication to addition, we couldn't add these because this is a square root of 3 and a square root of 8. They're not like radicals. All right, so here is the rule. When multiplying radicals, you can do these two things. Highlighted things are the 2 times you can multiply radicals. If you have the same radical, you can multiply them, or if you have the same base, you can multiply them still. And I'll explain why in a second. Write down that rule though. Like, you need to know that. If you can multiply, you can multiply 2 radicals together if they're under the same radical, because then you just put them under the same radical. And if they have the same base, you can also multiply them, and I'll show you why next. So does everybody have that rule written down so you can just watch the math happen? Or do I need to give you another minute? Question. Okay, so everybody, because these are under the same root, we can just put them under the same root, 5 times 3. That's why this one works. So that's the square root of 15, which didn't simplify. Now, this is the reason this one works. Pay attention. We know how to rewrite these with rational exponents, correct? So isn't this base 5 to the rational exponent? Roots go on bottom, remember last time. So there's a 2 on bottom, and what's my power? 1. And then we have times. Now looking at this piece, we have base 5. We're writing it with a rational exponent instead. 3's on bottom, what's my power? Now we know properties of exponents. We've been practicing this from day 1. When you multiply the same base, you add your exponents, correct? So take your calculator quickly. 1/2 plus 1/3. Math, enter, enter. So base 5 to the 5/6. Now everybody, don't make the tragic mistake in the future of doing 5 times 5 is 25. No, when you multiply the same base, you add your exponents, the base stays the same, correct? So we have 5 to the 5/6. Now here's the general rule of thumb. People always get confused and they say, well, do I write my answer as a rational exponent or as a radical? Well, did your problem start out as a radical or rational exponent? Radical, right? So we need to write this as a radical as our final answer. So my root is 6. So this would be a 6th root of 5 to the 5th power. Everybody good with that? All right, here we go. Number 35 we've already done, and 36 we've already done. Here we go, 37 and 43. So if we're multiplying these, there's a couple times we can. Aren't these both square roots? So we can multiply them together. Do it smartly though. Don't make your life harder than it needs to be. This is -2 times the square root of 5 times 20. Am I going to multiply those together? No, because then I'll have to re-split them apart. 20 breaks down into 5 times 4. 4 breaks down into 2 times 2. Now we're pulling out groups of 2 since it's a square root. So we'll pull out a 5 for those 2 5s. We'll pull out a 2 for those 2 2s. Because we're really just doing the square root of 25, which is 5. Square root of 4, which is 2. Does everybody understand? Nothing was left under our house, correct? So we pulled out a negative. We already had a -2 on the outside. We pulled out a 5. We pulled out a 2. -2 times 5 is -10 times 2 is -20. Not bad, right? Are you guys comfortable to do that, the next one? Could we just reorder this, right? Multiplication can be reordered. So we would have -2 times -4 times the square root of 4 times the square root of 20. Do you see how I just reordered it? So that's 8 square roots of 4 times 20. And then 20 breaks down into 4 and 5. Am I going to break down 4 more? No, because isn't there 2 of them? That's true. It's 32 square roots of 5. Questions? Are you guys good? Okay, sweet. So do these ones before lunch. 35 through 44 go. You have 2 minutes. Get some done though. Okay, so now we're going to go to adding and subtracting radicals. So there is a very strict, there's only one instance when you can add and subtract radicals. They have to be like radicals. And to make them like radicals, both things have to be true. The root has to be the exact same and the base has to be the exact same. Does everybody understand? Exactly the same to be able to add them. To be able to combine like terms. So x plus 2x equals 3x, true? Is that true? Yes, those are like terms, so we combined like terms. Did you write down the rule? I didn't see anybody writing. Okay, write that down. All right, everybody focus. So, x plus 2x, those are like terms, that's 3x. So 1 square roots of x plus 2 square roots of x, like terms. How many square roots of x does that give us? 3 square roots of x. Okay, 2 square roots of 3 plus 5 square roots of 3. Can I combine them? Yes. That's 7 square roots of 3. Does everybody understand? Now looking at this next one. 2x, now we've thrown in an x, so 2x square roots of 2 plus 5x square roots of 2. Now we have an x multiplied to the square root of 2. That has to be the same as over here. Are they alike? Yes. So 7x square roots of 2, yes. Yes. So x and x are like terms, so we can combine them. You wouldn't be able to combine them unless this part is the same and this part. All right, so look up here. The square root of x plus the square root of 3. Can we add them? No. No. Why? The base wasn't the same. Correct, everybody? Okay, looking at this next one. 1 square root of 2 plus 2 square roots of 3. The base is not the same. Okay, careful here. 2 square roots of x plus 3x square roots of x. No. There's an x there. Right. We cannot add these. Does everybody understand? Yes? Okay. Here we go. 51. 3 square roots of 3 plus 2 square roots of 45 plus 3 square roots of 45. Let's combine what we can right here, right now. So we have 3 square roots of 3 plus how many square roots of 45?
5 square roots of 45.
Yep, 5 square roots of 45. Does everybody see why? Yeah. And you say to yourself, that is my answer, but does my answer simplify? If the radical is not simplified, it's not considered simplified. In fact, we need these to be simplified to ensure maybe that's secretly, when it simplifies, going to be a 3 under there, and we don't know. Does that make sense? So let's simplify it. 9 times 5, 9 breaks down into 3 times 3. Okay, let's keep simplifying. So we have, on this, we still have 3 square roots of 3. And then on this piece, we just pulled out a 3, correct? So 5 times 3 is? So we have plus 15 square roots of 5. Now it's simplified all the way down. Can we combine them? No, but this would be the appropriate final answer. Simplified all the way down. Everybody good with that? Now, once again, the reason we also have to simplify them all the way down is because maybe that would have been a 3 in disguise. We would have been able to combine them. So I call it the wolf in sheep's clothing. You've got to have it all the way simplified down to know if you can actually add them. Here we go. Here we go. Let's do this one. Looking at this one right now, can we add anything? Okay, let's simplify it. 20 breaks down into 5 times 4. 4 breaks down into 2 times 2. Pulling out groups of 2. 2 times 2 is? So this piece, I'm just focusing on that, is 4 square roots of 5, correct? We multiplied it to that too. Let's change colors, and we have this, and it doesn't simplify, so we have minus square root of 3, which is just really minus 1 square roots of 3. Changing colors again, simplify that. 4 times 3, 4 breaks down into 2 times 2, and we're going to keep simplifying. Careful here. Negative 2 times 2 is negative 4. Left under our house is a 3. So now you look at this and say, can I combine anything? 4 square roots of 5, no other square roots of 5, and then we have minus. Good question. Everybody good? So then we have what's negative 1 square roots of 3 minus 4 square roots of 3? Square roots of 3. Okay, good. That would be our final answer, right? Okay. Everybody comfortable with adding and subtracting? Okay, then practice and you'll become comfortable. I think you're good. Do 51 through 59, check them off with me when you're done. So, today we're going to be dividing. We've already multiplied, added, and subtracted. We're going to be dividing radicals in a sense. Mostly we're just going to be rationalizing denominators. Now, once again, why we have to rationalize denominators is because it's just considered not simplified if there's a radical in the bottom of a fraction. which we've already learned how to rationalize denominators to an extent. After this unit, we're going to have to be able to rationalize tons of stuff. So everybody look up here. 3 over the square root of 2 doesn't simplify anymore, except, well, I mean, we can't do anything with 3 and the square root of 2. It's just considered a not simplified answer to have a radical in the bottom. So what we're going to do is rationalize it. I need you to think of it a little differently, so watch. Yeah, but I want you to think about this for a second. This is going to help with the harder ones. So, don't we need something to get rid of a square root? Don't we need to have something squared? Then root would cancel out power, correct? So if there's 1, 2, how many more 2's do we need to make it 2 squared? 1 more 2. So I'm going to multiply by the square root of 2. Does everybody understand why? Now if I do that to the bottom, I've got to do it to the top. Otherwise, I've changed things. When I saw you guys doing this on the last test, you were just saying, I'm going to multiply by 2 over 2. It's got to be a square root or else you can't put it under the square root. Does everybody understand? So now we'll multiply straight across. So 3 times the square root of 2 is just 3 square roots of... Can you multiply something that's under a root with something that's not? No. So we have 3 square roots of 2. Is everybody following me? Now on bottom, what we really have is this. The square root of 2 times 2, which is 2 squared. Now doesn't root cancel out power? So we have just a 2 on bottom. Everybody good with that? Let's do one that's a little bit harder. So look at 35 on the worksheet. Notice this is 45. We're going to want to rationalize this the smallest way possible so we don't have to do a lot of simplification. If you go about this the wrong way, you're going to have a nightmare of simplification. So let me suggest something. Let's rewrite 45 as its prime factors. So let's rewrite this problem. 3 over the cube root of, what does 45 break down into? 9 times 5, and 9 breaks down into 3 times 3, correct? If we would have went with 4 double factors, same thing, right? So we have a 3 times 3 times 5. Everybody rewrite that. Now we haven't changed anything. We still have a radical in the bottom of a fraction. We've just rewrote it into its factors. Now the reason I did that is so I can multiply by the least amount of stuff so I don't have to simplify any radicals. So let's think about it. It's to make a cube root cancel out, don't we need something to the 3rd power? All right, so we're going to multiply by the cube root of, we have 2 3's. How many more 3's do we need to make it 3 cubed? 1 more 3. So we're going to multiply by 1 more 3. Does everybody understand? Now 5. There's only 1 5. We need it to be 5 cubed. So how many more 5's do we need? 2 more. So 5 times 5. Now that's what we're going to use as the rationalization. So if you do that to the bottom, you've got to do it to the top. So we're also going to multiply, and we're not changing it because we're multiplying by a fancy 1, as I like to call it. So that's what we're looking at. Now I have always had people go, oh, those divide out. Well, yeah, we just did that on purpose. We made it a fancy 1, so of course it divides out, right? So now we'll multiply straight across. Now we'll look on top. This makes our life much easier. 3 is on the outside, so we have a 3. Cube roots. Now look, is there 3 of 3, 5, or 5s? There's 3 of them on top. No, so will anything come out? No. Nope. So multiply them together. 3 times 5 is 15. 15 times 5 is?
40. No.
Is it? Yeah, it is. Okay. Now on bottom, I want you to think about it. We technically have this, the cube root. We have 1, 2, 3 3's, so that's 3 cubed. And we have 1, 2, 3, 5 cubed, true? So root cancels out with power. So left on bottom is 15, 5 times 3. So we have 3 cube roots of 75 all over 15. Now that is my answer, but does my answer simplify? Multiplication, you can divide out, correct? We know that. We know how to simplify fractions. We just did a whole unit on it. Multiplication can divide out. Can we ever divide something that's underneath a radical, something that's not? No. So doesn't this become 1 over 5? So our final answer is the cube root of 75 over 5. Can I divide some, didn't remember, good question. Good question. Look right here. Wasn't this what it was before we multiplied it? And we knew there was not 3 of them. Good question. Any questions other than that? Let's do one more. Last one. So So, well, no, do you think you could do this one without me? Do you want me to do one more? Okay. So, let's rewrite it. We have 3 over the 4th root of, let's write it in its factors so we can multiply by the least amount of stuff. 135, some factors, somebody. 5 times 27, 27 breaks down into 9 times 3, 9 breaks down into 3 times 3, true? Yeah. So we have a 5 and we have 3 times 3 times 3. So what are we we're pulling out groups of 4, it's a 4th root. So what we're gonna rationalize by, think about it, we need, to get rid of a 4th root, we need something to the 4th power. How many more 5s do we need? 3 more. So can I go 5 cubed and not throw anybody off? Okay, we have 3 3s. How many more 3s do we need? 1. Now we'll do that same thing to the top. 4th root of 5 cubed times 3. So now we'll multiply straight across. So on top, we have a 3 on the outside. And then we have a 4th root of, let's look underneath the radical. There's 3 5s. We need 4 to pull it out, correct? So those are going to stay. Only 1 3. So take your calculator. Do 5 to the 3rd times 3. Tell me what it is. So I don't know. 5 to the 3rd times 3. Okay, so there's a 375, which we know doesn't simplify. Now on bottom, don't we have this? The 4th root of 5 to the 4th, correct? Yes. And 3 to the 4th. So ding, ding. And so 5 times 3 is 15. And then that simplifies, right?
Yes.
3 and 15. Can't we simplify multiplication? 1 and 5. Everybody comfortable? Okay. This is actually the last one that I have to show you because otherwise you won't be able to do it. Okay, so guys, we need to rationalize the denominator. So, is it 9 3 times 3? Okay, so how many more 3's do we need? 1. Now we can't just multiply by 3. Make sure you write cube root of 3. Now if I do it to the top, bottom, I've got to do it to the top. Now think about it. If I say to you, I'm multiplying out the top, don't we have 2 terms? So if I say multiply this to the top, don't we need to put parentheses if there's 2 terms? All right, let's multiply this out. Cube root of 3 times negative 1. Negative 1 cube roots of 3. Then we have cube root of 3 times cube root of 3. Can we multiply them? What's it going to be? Yep, plus the cube root of 9, correct? 3 times 3 is 9. Does that simplify? No. 3 times 3, we can't pull groups of 3.
You can multiply them in radicals.
Right. And then on bottom, what is it going to be without me having to write it out? 3, right? 3 cubed? But it will be, sorry, the cube root of 3 cubed is what I meant. Sorry, right? On bottom, isn't that what we have? So 3. Now you'd say to yourself, can I divide those out with something that's not under a root? Heck no. So we're done. Okay, finish the worksheet, check it off with me, then hand it in.